If you blow some powdered sugar over a flame, you get an impressive fireball. You get an even more impressive fireball if you blow powdered milk over the flame, and that's because there's oils and fats and the powder is very much smaller, and you get this huge fireball out of it. Now, I'm pretty sure everybody also knows that if you blow this stuff over a flame, you get an amazing fireball, because we've done this in a couple of videos and explained the chemistry of it, explained why it works, but basically, iron powder burns. Rusting's a kind of burning. Well, we have it in a fine powder, it burns impressively. Now, of course, if all you're interested in is pretty fireballs, you could try lycopodium powder. Lycopodium powder, the Cedar Ferns collected it and used to use it as dust material for latex gloves, but the fireball it creates is astounding. But it turns out that that's not escaped people, and the Dutch have been working with this to create a iron powder driven furnace. This stuff, when you actually just got it as a powder, there's absolutely nothing. It's incredibly safe like that. That is not going to spontaneously combust. If you spill it, you pick it up with a magnet and put it back in the bottle that it came from, or hoover it up. Nothing's going to happen. It is one of the safest materials we have got that we can burn. And of course, when it burns, guess how much carbon dioxide it produces? I can tell you, none at all. It doesn't produce carbon dioxide, it doesn't produce carbon monoxide, it produces iron oxide, or rust. So what's better with this stuff is you can actually completely recycle it. There is no waste at all. So this, in my books actually, is one material that can be considered the perfect fuel. Now, it gives out something like 5.2 megajoules per kilo of heat energy when you actually burn it. A production of it, of course, is just huge. I mean, it's the fourth most abundant material in the Earth's crust, and 80% of the mantle and the inner core is made of iron. It's very abundant in the Earth. It has a huge industry. We produce megatons of this every year, and the industry itself is perhaps not the greenest, but it does know that, and it is striving quite hard with hydrogen plants, etc., etc., to become more green. So one half of the equation, the production of this, is completely in place. The other half is collecting that rust and recycling it so that we actually have no use of materials. I mean, if you'd suggested that any other time in our existence, I would have burnt you at the stake as a witch, because that's incredible. We have a fuel we can recycle endlessly, and there's no waste and no loss in that fuel. I mean, there's going to be losses, obviously, people spill stuff, but that is an incredible fuel. So it's safe, high energy density, completely circular in its recycling, mass produced right this very minute. I mean, what more could you want from a fuel? And of course, the Dutch have been working on a furnace that runs this. And that's a 20 kilowatt hour furnace, which is about the same as your water boiler if you're using a domestic heating system. And they're doing the same thing. They're running a Stirling engine with it to generate electricity, and they're heating up water so that we have central heating run from this. But as a spot room heater, of course, it just stand in the corner. Now, powders we think of as being slightly more difficult to handle than liquids, but have you ever seen a sandblaster? We know exactly how to powder something and how to spray something as a powder into the air to get that oxygen powder mixture to get the burn that we want. It's really not a matter of inventing the new technology, but of putting that technology together. Now, obviously, on the exhaust, we get in iron oxide and we want to collect that, and you collect that in a cyclone. Now, cyclones, again, are not that new anymore. The Dyson Hoover introduced the cyclone, and now just about every Hoover's got one. So if you empty that exhaust into a Hoover, it'll spin round in the cyclone and collect the iron oxide, and that's that. That's pretty amazing from where I stand, because of what it means is you can have a room heater where the only thing that's being produced is hot air, maybe hot nitrogen basically, because all the oxygen's taken out, but you're not going to be producing carbon monoxide, you're not going to be producing carbon dioxide, and so you don't have nearly the same worries about it. And as I say, this is not something you're going to spill on the ground and then worry about. So news of this first came out in 2020, but the group at Eindhoven Technical University have taken this one stage further, and at Boodle they've built a 1 megawatt plant to demonstrate it. And of course this has meant that there's a whole load of startups now looking at this as a clean energy source, and it's become so intriguing and convincing of it being able to do what it says on the tin that the group is now working with the Canadians and with the European Space Agency and with NASA as this fuel is a safe and powerful fuel to be used in lunar modules for lunar habitation. So it's an absolutely fascinating subject. We did look at it before, but I wanted to do the update on what's happening with it. I hope you enjoyed the video. Thank you very much for watching, and please do remember to like and subscribe.